Good morning, students. So, in the previous class, we discussed about numerical differentiation and numerical integration. So now, I think maybe from this class to at least 4 to 5 to 4 class, we will discuss solving differential equations using numerical methods, and then solving partial differential equations by numerical methods. So these are the remaining two sections in the third unit. I think probably I will finish it the middle of next week. Otherwise, at least the end of the next week. Okay. So the first method to solve the differential equation is the Taylor series method. So we studied the Taylor series in semester 3 in the analytic functions. Okay. Now using Taylor series method, we are going to solve the differential equation. Okay. So consider the one-dimensional initial value problem. Dy by dx is equal to y dash is equal to a function of x comma y, where y of x naught equal to y naught, where f is a function of two variables x and y, and the point x naught and y naught, x naught comma y naught is a known point on the solution curve. So purpose of Taylor series. So Taylor series is an idea used in computer science, calculus, chemistry, physics, and other kinds of higher level mathematics. So Taylor series is used to create an estimate of what a functions look like. Taylor's polynomial is an essential concept in understanding numerical methods. Taylor series is a single step method and works well as long as the successive derivative can be calculated easily. So to find the numerical solution of the first order differential equation, even you can solve the second order differential equation, simultaneous differential equation. So that is not in your syllabus. So first order differential equation, solving first order differential equation using numerical methods. Okay. So to find the numerical solution of the equation dy by dx is equal to function of x comma y, given the initial condition y of x naught equal to y naught. So Taylor series formula. So this is the Taylor series formula. Yn plus 1 equal to Yn plus h by 1 factorial into Yn dash. That is a derivative of Yn plus h square by 2 factorial into Yn double dash plus h cube by 3 factorial into Yn triple dash plus and so on. So here it is given what is the Yn power rth derivative. So dr power y by dx at the point xn comma yn. At the point xn comma yn. So this is the first problem. Solve dy by dx is equal to x plus y, given y of 1 equal to 0, y of 1 equal to 0, and we need to find the y of 1.1 and the y of 1.2 by Taylor series method. So what is given the question? So dy by dx is equal to x plus y is given the question. So you can write dy by dx is equal to y dash. So y dash equal to x plus y. And one more thing, the initial condition is given, that is y of 1 equal to 0, that is given. So this implies x naught equal to 1 and y naught equal to 0. So this is x naught. This is x naught. So actually this is x naught. Okay, x naught, this is y naught. Okay. So x naught equal to 1. It's not equal to 1 and y naught equal to 0, and h value is 0.1 because x naught is 1 and x1 is what? X1 is 1.1. x2 is 1.2. Okay, so h is 0.1. Okay, so now what is given the question? Y dash is equal to x plus y. Now from this find y double dash. Y double dash is equal to, you should differentiate with respect to x, so 1 plus y dash. So if you differentiate again, y triple dash is equal to 0 plus y double dash. So if you differentiate again, y fourth dash is equal to y triple dash. So I think you know how it behaves hereafter. Okay, now correspondingly you should find, correspondingly you need to find y naught dash. Y naught dash is equal to x naught plus y naught. X naught plus y naught. What is x naught? X naught is 1, y naught is 0. So 1. So y naught dash is equal to 1. Similarly, for y double dash is equal to 1 plus y dash, you need to find y naught double dash. Y naught double dash is equal to 1 plus y naught dash. So 1 plus y naught dash is 1. So 2. So y naught double dash is 2. Similarly, for y naught triple dash is equal to y naught double dash. Y naught double dash is equal to 2 from the previous value. So y naught fourth derivative equal to y naught third derivative, that is 2. Okay. Now you should write the Taylor series formula. Say Taylor series, by Taylor series y1 equal to here it is given yn plus 1. So if you substitute n equal to 0, you will get y1. So y1 equal to, we substitute n equal to 0 in the formula, we will get y1 equal to y naught plus h by 1 factorial into y naught dash plus h square by 2 factorial, y naught double dash, and so on. So you need only you need h value, and you need what? Y naught dash, y naught double dash, y naught triple dash, and so on. So you know that h is equal to 0.1 and y naught dash, y naught double dash values are here. Y naught is 0, y naught dash is 1, y naught double dash is 2, y naught triple dash is 2, y naught fourth derivative is 2. So now if we substitute in the formula and you need to use a calculator, you should simplify and get the answer. So this is y1 equal to y of x1 is 1.1 is equal to 0.110333833. So next, take x1 equal to 1.1, take x1 equal to 1.1, and y1 is this value, you know that, and the h is 0.1. Now I am going to find y2. Y2 is y of x2. Y of x2 is what? Y of 1.2. So again, same procedure. Okay, y dash is equal to x plus y. That is given the question. Okay, and you need to find y double dash, y triple dash, and so on. And correspondingly, you need to find. Last time we found y naught dash. Now you should find y1 dash. Y1 dash is equal to x1 plus y1. X1 is 1.1. Y1 is from the previous iteration. I have the value 0.11033833. So y1 dash value is 1.21033833. Similarly, from y double dash is equal to, we know that 1 plus y dash, y1 double dash is equal to 1 plus y1 dash, that is equal to 1 plus y1 dash is the value 1.21033833. So you need to add. The procedure is similar to, very similar. Okay, so y triple dash is equal to y double dash. Okay, I think you can easily do up to this level. Even in next you need to substitute n equal to 1 in the given formula. So you'll get y2 equal to y1 plus h by 1 factorial to y1 dash and so on. So y2 equal to y of x2. X2 is 1.2. So here you should know the value h and y1, y1 dash, y1 double dash. So everything just now we found out. You should just substitute the formula, and using calculator you should do it carefully and get the answer. So the second problem is also same idea. Okay, using Taylor's method, compute y equal to 0.2 and y equal to 0.4, correct to 4 decimal places, given that dy by dx is equal to 1 minus 2xy and y of 0 equal to 0. So I will tell how to find y of 0.2. The same procedure you need to apply y of 0.4. So y dash is equal to dy by dx, that is given, that is 1 minus 2xy. So y dash is equal to 1 minus 2xy and y of 0 equal to 0. That means x naught, this is x naught is 0, and this is y naught, this is y naught is 0. So h is equal to 0.2 because y naught is 0 and y1 is 0.2 and y2 is 0.4. The common difference is 0.2. So h is equal to 0.2. So next y dash, that this is given the question. So you need to find y double dash. So 0 minus 2 into uv rule. So x into y dash plus y into, if you differentiate x, 1. So y double dash is equal to minus 2 into xy dash plus y. Next y triple dash is equal to minus 2 into, so here again uv rule. So x into y double dash plus y dash into 1. If you differentiate y, you will get y dash. And then y triple dash minus 2 into, again here, sorry, I think simplification, y triple dash is equal to minus 2 into x y double dash plus 2y dash. Next, y power fourth derivative. Similarly, you should find y power fourth derivative, y power fifth derivative. So now, correspondingly, you should find y naught dash, that is equal to 1 minus 2 into x naught into y naught. So x naught value is 0 and y naught value is also 0, 0, 0. So y naught dash is equal to 1. Similarly, from y double dash, I'm going to find y naught double dash. Y naught double dash is equal to minus 2 into x naught into y naught dash plus y naught. So minus 2 into x naught is 0, y naught dash is 1, and y naught is also 0. So finally, you get y naught double dash is equal to 0. So from y triple dash, I'm going to find y naught triple dash. So minus 2 x naught y naught double dash plus 2 y naught dash. Okay, because these two are equivalent. This is a simplified form. So minus 2 into x naught is 0, y naught double dash is also 0, plus 2 into y naught dash is 1. So finally, you have minus 4. So next, you know y power fourth derivative. So y naught fourth derivative is minus 2 x naught y naught triple dash plus 3 into y naught double dash. So x naught is 0, y naught triple dash is minus 4 plus 3 into y naught double dash is 0. So I'll get 0 finally. So similarly for fifth derivative, and this is a Taylor series formula. The general formula, if you substitute n equal to 0, you get y1. Anyone knows his name? I think his name is very new to me. Any idea? Is he your classmate? Please reply.
No, sir. We don't know,
Okay,
sir.
thank you. Okay, now, so n equal to 0. If you substitute n equal to 0, you get y1 equal to y0 plus h by 1 factorial into y0 dash, and so on. So substitute the values just now we found, okay, and using calc, you should find the value of y1 equal to y of 0.2. Okay, now you should take x1 equal to 0.2 and y1 equal to 1.9475220003 and h is equal to 0.2. Again, you should proceed the same idea, okay, which is similar to the previous one. You can find y2. y2 is y of 0.2. Okay, so now before, okay, this is a practice problem I gave to you, but now I want to solve one problem here, because at least one problem we will do it in the class. So third problem. So now I'm choosing the third. I am expecting the answer from your side. So using Taylor series method, find y of 1.1 and y of 1.2. Correct to four decimal places. Correct to four decimal places given dy by dx equal to x into y power 1 by 3 and y of 1 equal to 1. So try this problem. So here y dash is equal to, okay, before going to y dash, y of 1 equal to 1. Okay, y of 1 equal to 1. Y of 1 equal to 1 implies x naught is 1, y naught is 1. And h is also 1.1, sorry, 0.1. Which is 0.1. Okay, now what is given the question? Y dash, that is dy by dx is equal to x into y power 1 by 3. Okay, now find the corresponding at the corresponding y naught dash. Okay, y naught dash is equal to x naught to y naught power 1 by 3 that is equal to, what is x naught? X naught is 1, y naught is 1, y naught is 1, so you get 1. So y naught dash is equal to 1. So next we find y double dash. Y double dash is equal to x into UV rule, x into 1 by 3, y power 1 by 3 minus 1 minus 2 by 3 into y dash plus 1 into y power 1 by 3. Now this is equal to x 1 by 3 into x, 1 by 3 into x, y power minus 2 by 3. What is y dash? Y dash is x into y power 1 by 3 plus y power 1 by 3. So this is equal to 1 by 3 x square, x into x square, y power minus 2 by 3, y power 1 by 3, so y power minus 1 by 3 plus y power 1 by 3. This is y double dash. So now find corresponding y naught double dash. So what is y naught double dash? 1 by 3, 1 by 3 x naught square into y naught power minus 1 by 3 plus y naught power 1 by 3. So this is equal to 1 by 3. X naught is 1, y naught is also 1, again y naught is 1. So 1 by 3 plus 1 is 4 by 3. Next you should find y triple dash. Y triple dash, okay. So please check it. I think you have 1 by 3 x square into y power minus 1 by 3. So I'm keeping x square by 3 as it is. If you differentiate y power minus 1 by 3, you get minus 1 by 3 into y power minus 1 by 3 minus 1, that is minus 4 by 3 into y dash. Into y dash. And then if you differentiate x square, you'll get 2x. You get 2x by 3 into y power minus 1 by 3 plus you have y power 1 by 3. If you differentiate y power 1 by 3, you have 1 by 3 y power 1 by 3 minus 1 is minus 2 by 3 into y dash. So just simplify. Y triple dash is equal to minus x square by 9 y power minus 4 by 3 into y dash plus 2x by 3 into y power minus 1 by 3 plus 1 by 3 into y power minus 2 by 3 into y dash. Okay. Now correspondingly you should find what? Correspondingly you should find, okay, y not triple dash. So y naught triple dash is minus x naught square by 9 into y naught power minus 4 by 3 y naught dash plus 2 into x naught by 3 into y naught power minus 1 by 3 plus 1 by 3 into y naught power minus 2 by 3 into y naught dash. So substitute and so x naught is 1 by 9, y naught is 1, y naught dash is also 1. What is y naught dash is 1 plus 2 into x naught is 1, y naught is 1 plus 1 by 3, y naught is 1, y naught dash is 1. Minus 1 by 9 plus 2 by 3 plus 1 by 3. So minus 1 by 9, 3 by 3 is 1. So minus 1 plus 9, that is 8 by 9. So 8 by 9. Now, so I think up to this is enough. Okay. So next I'm going to write the Taylor series expansion. Y1 equal to y naught plus h into y naught dash plus h square by 2 factorial into y naught double dash plus h cube by 3 factorial y naught triple dash plus. So substitute the formula and using calculator do it and tell the final answer. So I am expecting the answer from your side. So y1 equal to y of 1.1, that is x1, y naught is 1 plus h is 0.1 into y naught dash. Y naught dash is 1 plus h square. H is 0.1, h square by 2 factorial into y naught double dash. Y naught double dash is what? 4 by 3 plus h cube 0.1 cube by 3 factorial is 6 into y naught triple dash. Y naught triple dash is 8 by 9 plus answer. So do it using calci and tell what is 1 plus 0.1 plus 0.1 whole square by 2 into 4 by 3. So please tell. Point 1 whole square divided by 2 into 4 by 3. So please tell the value. So I think I got, please tell, 0 point?
0.00666.
I got this answer, 0.00666. So please once again check it, 0.1 whole square by 2 into 4 by 3.
Zero 0.0029.
Okay, first, what is 0.1 whole square? Okay, equal to, sorry, 0.1 whole square equal to 0.01 divided by 2. Divided by 2 is what? 5 into 10 to the power of minus 3. Yeah. So into 4. Into 4, I am getting 0.02. 0.02 divided by 3. Divided by 3, I got 6.6666. So only 6 into 10 to the power of minus 3. So 10 to the power of minus 3 means you should put 3 places. You should put 0 point. I think I got this answer. So anybody got this answer?
Yes, sir. Correct only, sir.
Yes, sir.
Why you are getting? What about your mode? You check it. I think degree mode is enough here, and I also degree mode. Please check the mode. Degree mode. Okay. Okay. Now I think some of you got the same answer. So practice is very essential. Okay. So you may think, so we have calculator, we can do. That is okay. If you solve the problem in the calculator, sometimes you'll get the error like this. But the problem is you can't cross check whether your answer is correct or not. So that is the main problem. Okay, you should be very careful. Next, 0.1 whole cube divided by 6 into 8 by 9.
0.00148.
0.00148.
Yeah, sir.
Okay, thank you. Plus and so on. So this is a Taylor series. This is the infinite series. So you should put plus dot dot dot. Okay, this is after adding this. Please check it. I will write the answer. If there is any correction, you can inform me. So 1.10681. Okay, I think there is no correction. Now, similarly, you should start with again. We start with x1, y1. x1 is 1.1. X1 is 1.1. Y1 is 1.10681 as a starting value. As a starting value. So x1 equal to x1 equal to 1.1 and the y1 equal to 1.10681. So again, now I'm going to ask from you, okay, because we know that already the derivatives. We know already the derivative, that is y dash is equal to this is the given column x into y power 1 by 3. Now correspondingly, it should, what is y1 dash using calculator, you should do it and tell. What is y1 dash? It is equal to x1 into y1 power 1 by 3. x1 is 1. Oh, sorry, x1 is 1.1. y1 is 1.1010681 whole power 1 by 3. So please tell what is y1 dash.
1.137.
1.13785. Okay. Okay. Next, y double dash. Okay, I'll write directly y double dash because already we calculated y double dash, that is 1 by 3 x square y power minus 1 by 3 plus y power 1 by 3. So y1 double dash is equal to 1 by 3 x1 square y1 power minus 1 by 3 plus y1 power 1 by 3. To simplify and tell the final answer. So x1 is
Excuse me, sir.
please tell.
Sir, sir, can't we calculate by changing the h value to 0.2 instead of derivating again and again?
0.2.
Yeah, sir. H value to 0.2.
Yeah,
It's much easier.
But the procedure is you should follow this procedure only. H is equal to 0.1 only. Okay, you can't directly follow. Actually, in the here the here how you, I don't understand how you will find directly.
Sir, let us consider y1 equal to y of 1.2.
y1 equal to y of 1.2. Okay.
Yes, sir. So that h value becomes 0.2 now, sir.
Okay, but you can't do like this. Okay.
Yes,
So
sir.
okay, so actually this is the procedure. So as per the procedure, we need to go. Okay, suppose okay, so suppose if you do like this, please do it in your notebook. I will check it. Please take a photocopy. In my free time, I will check it whether it is correct. I think it is not correct, so I want to double check with you whether your method is correct or not. So please, if possible, you can do it that using that method. Send to me my personal WhatsApp. I will check it. Okay. So may I know your name?
Vamshi, sir.
Vamsi. Okay. Thank you. Okay. Now what is the y1 double dash?
1.4243.
1.42433. Okay. Okay. Now similarly, next y1 triple dash. So directly find y1 triple dash. Have you got the answer? y1 triple dash. Wait, it takes time.
0.9.
Yeah, 0 point. Okay, 0 point.
92981.
Okay, 92981. So I got a 92978. Okay, 87. So if it is very near to this value, okay, no problem. And then final value, that is y2 equal to y1 plus h into y1 dash plus h square by 2 factorial into y1 double dash plus y3 by 3 factorial into y1 triple dash plus and so on. Okay, so y of 1.2 is 1.22772. So please check the answer. If there is any deviation from this answer, you can inform to me. Okay. So now, just I'm going to introduce the next method. The next method is Euler method. Next method is Euler method. Okay. So the aim of this method is again to solve the first order differential equation given the initial condition y of x naught equal to y naught. Okay. Actually, here it is mentioned here in solving first order differential equation by numerical methods. Just we come across only one type of solution. Actually, there are two types of solution. But we come across only one method, that is the Taylor's method. Picard's method is also there, but it is not in your syllabus, Picard's method. So there are two types of solution. So one is a series solution. One is the series solution, that is by Taylor series and the Picard's method. You can get the series solution. A series of y in terms of x, which yield the value of y at a particular value of x by direct substitution in the series solution. Second one is the values of y at specified values of x. So there are two types of solutions. Okay, the method Taylor's series method and the Picard's method okay, belongs to the first category. And method due to Euler, we are going to study Euler, Ranjikuta, Adam Bashworth, and Millian comes under the second category, that is values of y at specified values of x. The methods of second categories are called step-by-step methods because the value of y are calculated by short steps ahead of equal interval h of the independent variable x. Okay, so Euler's method. So aim to find the numerical solution of the equation dy by dx is equal to f of x comma y. Given the initial condition, y of x not equal to y naught. So in Euler method, we approximate the curve of solution by tangent in each interval. By the tangent in each interval, that is by sequence of short lines. A sequence of short lines. Unless h is small, the error is bound to be quite significant. This sequence of lines may also deviate considerably from the curve of solution. So Euler's formula, yn plus 1 equal to yn plus h into f of xn comma yn. So this is the Euler formula. So yn, that is our so yn plus 1 is depending upon the previous iteration value and h value and the function value at in the previous iteration. So where n varies from 0, 1, 2, 3, etc. So this is the first problem. Okay, so y dash is equal to minus y. The problem is dy by dx is equal to minus y, and y of 0 equal to 1. Y of 0 equal to 1, and determine the values of y at x is equal to 0.01 and within bracket again 0.01 and the next 0.04. This means this is the starting value. That is, this value is x naught, this value is y naught. So and hence this is x1. X1 is 0.01, and this is h value. The second one is h value. H is also 0.01. That means x2 is what? 0.02. x3 is 0.03. So this is the last value. This is a starting value. This is the last value. This is a common difference. x4 equal to 0.04 and h is equal to 0.01. Okay, now so corresponding to x1 to x4, we need to find y1, y2, y3, y4. So that is the problem. We have to find y1, y2, y3, y4. For this, I'm going to use the Euler's formula. Yn plus 1 equal to yn plus h into f of xn comma yn. So let us take n equal to 0, substitute n equal to 0 in the formula. So we'll get y1 equal to y of x1. What is x1? 0.01. That is equal to y0 plus h into f of x0 comma y0. Okay, that is y0 is given the question. Y0 is what? 1 and x0 is 0. So y0 is 1. H is what? That is also given the question. 0.01. F of x0 comma y0. What is f of x comma y? F of x comma y is minus y. F of x comma y is minus y. So f of x0 comma y0 is minus y0. So 1 plus 0.01. Y0 is what? y naught is 1, so minus 1. Remaining part is simplification. Now we got y1. Similarly, if you substitute n equal to 1, you'll get y2. y2 equal to y1 plus h into f of x1 comma y1. So y1 is just now we found y1 0.99, h is 0.01, f of x1 comma y1 is from the function. We know that f of x comma y is minus y, f of x1 comma y1 is minus y1. So simplify and get the answer. And n equal to 2 will get y3, and n equal to 3 will get y4. So the same procedure, that's why I'll skip quickly. Okay, and this is the second problem. So again, we will discuss Euler's method if possible tomorrow. I think tomorrow at least I will solve one problem in the classroom. Okay, what is this problem? This is y dash is equal to x plus y. Y dash is equal to x plus y. Okay, so before that, I want to share one more information with you. Okay, just now I received a message. Okay, actually, this is about the internal pattern for all senior classes of both UG and PG, as per the Dean School of okay, SASH from my school. Okay, the pattern is best 4 performances out of 6 accounted for 20 marks. Accounted for 20 marks plus 5 marks for assignment. Okay, so this is the okay, for internal marks. I think you have for 25. I think last semester I think there is no marks for assignment. I think so. Okay, this semester best 4 performance out of 6, so accounted for 20 marks plus 5 marks for assignment. I think I gave only 2 assignments, so I think I need to give 2 more assignments. Okay, I will prepare the questions and then I will post as early as possible. And also prepare very well for the final exam. Okay. Okay. Usually, you know that it is online exam. The question paper is not direct. It is not direct questions. So you should be prepare very well. So we will discuss about the question paper later. Okay, still you have time. Okay, but just I am telling you, you should concentrate more and refer some other book, some other materials. Okay, and also I will share with you what I have. If I found anything new, I will share with you. Okay. I think time is nearly 9:45. Okay, we will discuss Euler's method again tomorrow, 6th hour. And if you have any doubts, you can ask to me. Vamsi, if possible, you can do it by that method. Send to me. I will check it. We will discuss again tomorrow, 6th hour. Okay. If you have any doubts, you can ask to me. Otherwise, you can leave. We'll meet tomorrow.